I think we're good. Okay. Just to start, most of you know me by name. I'm Piers Jiggens. Most of you know I work for ESA. That is unchanged, but what is changed is I am now in exploration, so human and robotic exploration, and I'm the science lead for radiation in that directorate. So this is a change of role, and this presentation will highlight a little bit the exploration vision, which you can follow this QR code there and see more about. And then how that links to radiation. And as we go on, I hope it touches more on things that are of relevance to you. So very briefly, if you see words like on the first slide, there was this Terrae Novae. This is the exploration vision at ESA. And if you see things like Explore 2040, that is the exploration strategy. So it's putting some more flesh on the bones of this vision. And if you see things like E3P, that's the European Exploration Envelope Program, and that is really each 3 years how we are implementing this strategy. And here, of course, we connect the HRE strategy, so the exploration strategy, into the ESA strategy. And what you can see on this slide is the 5 overall objectives for what's called the ESA strategy 2040, and the second one, which is Explore and Discover, relates directly to exploration. So that's just some preamble, but also to warn you, if you follow these links, what some of those things mean, because even for me, moving into exploration, they were not intuitive, let's say. So what is the exploration strategy? So it's a multi-destination strategy where we try to have a single vision linking those things. So for exploration, we're talking about low Earth orbit, where we are now, and maintaining a presence there and having more sort of commercial aspects there. Going beyond low Earth orbit to allow Europeans to explore the moon, and preparing to take Europeans to Mars at the end of the 2040s. And something I want to read from the strategy here is it says, Europe must foster a science and knowledge-driven thread for exploration as a goal commonly shared with all spacefaring nations. And I say this because science is really foremost in the strategy, which should be a good sign for this community. And in essence, what we're saying here is that the European exploration strategy has in the past been very dependent on other parties. And the intention is that we have European self-determination to pursue exploration goals. Being in this stronger position will allow us to have more meaningful collaborations without being prevented from implementing our strategy when other people make different decisions, let's say. So what's being proposed at what's called CMIN 2025, so that's the Council on Ministerial level. That's every 3 years. ESA has its this meeting, and it's going to be in November, and it defines the budget for the coming 3 years. What you can see here is the multi-destinations. You can see, as I mentioned before, commercial exploitation of LEO, a lot more in the lunar domain, including Gateway, Argonaut, which is a lunar lander, small missions, so they can be orbiters, they could be landers as well. There are some concepts for those. And then Mars robotic exploration, including Mars sample return, Rosalind Franklin, Lightship, which is an electric propulsion tug, so like to transport payloads to Mars, and then getting into the future more precision and heavy landing. So I should say that this slide, it predates the NASA skinny budget of the 2nd of May, proposing a 6 billion cut. And of course, whilst we have this vision to have some self-determination, including these collaborations in the short term, there were a lot of interdependencies. So what's happening now is that there is a discussion in the directorate with how we modify the strategy, and we don't know for sure what comes out of those NASA decisions, because we don't know that they are fixed until the Congress approves them, for example. So it's a difficult time, and for us, the ministerial comes at a difficult time with all these goings on. But I will focus on what doesn't change. Yep. So for science, there are now 2 types of science within exploration. And one of them is called exploration-enabled science, and the other is exploration-focused science. Exploration-enabled science you can think of as all the science we kind of used to do in exploration, but also in the science directorate, which is opportunistic. Let's say you either have a defined mission to achieve something, but the science is often done in the member states based on the data that is delivered and made available by ESA. But in addition, in exploration, we have this what's called exploration focused science, which is enabling. So it's the science we need to do in order to achieve the goals in the 2030s and 2040s. And that, you can imagine, will link directly to exploration. So exploration enabled science could be anything, right? I mean, it could be any science that you are able to do via a kind of exploitation of the payloads that exist, or opportunistic payloads through announcements of opportunity. But exploration focused science has these 4 different domains. I'm going to come on to them in a bit more detail in I think the next slide or the one after. But what is important to note is that it's driven by the programmatic needs. It has a close link with technology de-risking, but it might go via ITTs. So that, I think, is the big difference, right? We would issue ITTs where we do science which enables future exploration, right? ITT is an invitation to tender. So it literally means the ESA would have a contract to do science instead of saying, here's all the data, you do the science with your national contracts or with EU funding or what have you, right? So it's a different way of doing things for exploration. Exploration enabled science, I will not spend too much time on it, but it's fundamental research which is enabled by the platforms and the data that we deliver. It doesn't change, but the focused science does, and there are these 4 domains: local resources, environments and effects, crew health and performance, and habitation. So these 4 domains are the exploration focused science domains. And what I've done is pull out where there is a link to radiation. So the second one will probably jump out immediately: environments and effects, environment modeling, SEPs, GCRs, storm forecasting, this kind of stuff. Crew health and performance, when we get into radiobiology, obviously there's a direct radiation connection there. Habitation, the geometry of the modules has a strong influence on the radiation field that the astronauts would see, and lastly, the local resources, well, the regolith of the moon and Mars, or the atmosphere of where we are, also has an impact. I won't touch too much on things like biophysical models and countermeasures in this presentation, but they are important, and that is something that we will aim to address as well. So, why is radiation important for exploration? Specifically in exploration, we have astronauts, and they're considered radiation workers. Spacecraft are larger and more massive than many other spacecraft. So that has more of a, means you need to do more sophisticated modeling of the radiation transport. Operations are influenced by a range of factors, including radiation. Okay, so you can imagine EVAs, things like this. Travel to the surface of the planetary bodies with associated variations in the radiation field, which I think I touched on before. This ALARA principle. So ESA has a duty to ensure that dose levels are as low as reasonably achievable. That, of course, once you're outside the Earth's magnetosphere, that means you need to say when you're going to have a radiation storm, because even if it doesn't exceed your limits, you haven't done your job if you haven't tried to mitigate the doses that the astronauts see. Impact is not purely short-term, but extends beyond mission duration. So this means that we don't immediately know whether we had a negative impact as a result of radiation doses in astronauts. There's impact on mission short-term and long-term operations planning, and it is seen as a showstopper beyond LEO, especially if you get to Mars, because of the mission durations and you start to approach these dose limits. So understanding radiation science is therefore a key enabler for our future exploration plans. And what we have done is divide the radiation field into 3 subcategories. Those are environments, particle transport, and radiation and radiobiology. So maybe for the audience here, the first 2 are more interesting, especially the first one. So understanding the charged particle environment, specification, forecasting, as well as what happened in a mission, what we observed. the particle transport through atmospheres, surface interactions, shielding moderation, dose quantities, and then onto the radiobiology, so actually how that impacts humans, if there are possible mitigation strategies, things like this. Going across these three domains, we have radiation instrumentation, so particle detectors, spectrometers, dosimeters, et cetera, and then also the ground test facilities, so that we can understand very well if our simulations of the environment inside habitats is appropriate. And of course, these can be extended to calibration of instrumentation as well. So radiation science, these are destination-specific needs. So again, there are three destinations: low Earth orbit, lunar, and Mars. I've added one in here, which is as we go beyond low Earth orbit. When we're in low Earth orbit, we might care about the inner Van Allen belt, geomagnetic shielding, specifically. As we extend beyond low Earth orbit, if we have a transfer trajectory, like for example, that was proposed for the first modules of Gateway, which is a long duration transfer, then when we will care about the outer Van Allen belt. And then we start to see solar particles extending to lower energies, which become important for EVAs. So the low energy SCPs often don't matter when we're inside the habitat or the spacecraft, but as we go on EVA, then obviously the energy threshold is reduced. In lunar space, magnetocell crossings, and then the interaction with the lunar regolith when we're on the surface. And then for Mars, we start to care about the interplanetary SCP environment and the variations from 1AU and when we're on our way to Mars and at Mars, how those things varied. The atmospheric interactions and also Martian regolith interactions as well. This slide is to highlight those things which are generic across the domain. So we're always going to be concerned about galactic cosmic rays for exploration. We are always caring about solar energetic particles, especially those extending to high energies, even if they become much more important as we go beyond LEO. We're always going to need to do particle transport to simulate the secondary radiation field inside a geometry and to perform those calculations. And we will always care about the radiobiological impact and how we can address these with countermeasures and how accurate our risk modeling is and those kinds of things. So for the instrumentation, the intention is to inform and verify our modeling for specifications or forecasting for use in operations and for, as I said before, post-event mission analysis of the doses or the anomalies that we saw. Types of instruments: particle detectors, spectrometers, cover an extended energy range of primary and secondary particles needed for exploration. So we care, and I think it's very relevant for this community, we disproportionately care about greater than 100 MeV protons. We care about heavy ions. We care about the introduction of secondaries and these kind of things. We care about galactic cosmic rays simply because you have a big structure and the interaction of that structure with these high energies is what's causing our effects. It should be complementary with other ESA assets, other European assets. So we don't exist in a vacuum. We would always look to exploit things coming from science, like the presentation from Eleni on EPD. Like if they are doing something, we would try to add the thing that we need specifically. And also, I think I should mention here space safety as well, and we have close connections with them. Dosimeters with human dose quantity measurements, so things that really like RAD on MSL, telling you about the dose quantities for humans, and some other experiments, which I'm not going to go into too much detail. Here you see a flat-sat makeup of the ESA instrument or payload for Gateway, which let's say it's in a bit of limbo right now. This is, I think, the most important slide in my presentation, which is that we have a newly opened announcement of opportunity on ideas.esa.int. I produced this QR code, and what we're looking for is a team. So it's in exploration, it's called a facility definition team. You can think of it as a science definition team. We're looking for scientists and instrumentalists, experts, in order to define what measurements we should be making and how we can be making those measurements for exploration, so to meet our goals. The AO is open now. It will close the 13th of July, so next month. Then there will be an assessment, and the intention is that it runs for 1 year from the 1st of October for 12 months. There will be funding for travel and attendance of meetings and those kind of things. It's not a contract. There will be individual what's the word? There will be some money made available for those kind of travel and attendance of meetings and your time, that kind of thing. But I would like to see this community well represented in that facility definition team. So the environment side of things, I think I mentioned before, so I can go quite quickly. We care about heavy ions, we care about high energy particles, and we care about electrons for the forecasting aspects. So we care about the things you care about. Also the temporal variations, so the short-term forecasting, but also the long-term solar cycle variations shouldn't be ignored. So when we have things like missions to Mars, just the GCR dose is often the thing that makes the mission a showstopper. Logically, that means you should fly at solar maximum, so you reduce it, and then that means it becomes even more important that you can accurately predict the solar particle events, such that you don't then exceed those dose limits. Then we've got particle transport. So I mentioned this before. We need to understand what the complex radiation field looks like inside a geometry and at different points within that geometry, because we might have things like storm shelters, and we need to fold those kind of analyses in with operational aspects. There can even be parts of your geometry that are the worst at most of the time, because you have some secondary emission and they generate more secondary radiation and more dose, but during solar particle events, they become the best. So it's complicated, and we need to be modeling all of these kind of interactions. But it's not just a spacecraft. For Mars, it's also the atmosphere, and for the Moon and Mars, it's also the interaction with the regolith, production of neutrons and things like this that can have a disproportionate impact on humans. Then radiobiology, I don't know that I will go into too great a detail here, but maybe just for some background, there are normally thought of as two types of effects, or two categories of effects: stochastic effects and deterministic effects. Stochastic effects are things which have the statistics really matter, because it's how a very small number of cells being impacted can result in a very severe effect, such as cancer. Deterministic effects normally is a significant fraction of cell loss, which results sort of more deterministically in an outcome like radiation sickness. And we then would look into assessing how these effects are coming about and what countermeasures you could foresee. I could talk a bit more about that, but I think it's more important to talk about the other things in the time that we have. Ground test facilities. So for exploration, we have a number of facilities that ESA is supporting. You can see here on the left-hand side, there are 5 of them that are seen as suitable for the kind of biological and physical effects of radiation. But there's also a 6th, which is GSI Fair in Darmstadt, which has now, well, they have very high energy and beams, as well as heavy ion beams, and they have now a GCR simulator to try to reproduce the actual galactic cosmic ray environment you see, similar to what they have in Brookhaven in the US. There is an announcement for opportunity for the 5 on the left. So if you're interested in applying for beam time, you can do via this QR code. There is also one for GSI. However, it closed recently, and there will be another one in the next 2 years, I think it is. Little piece of advertising. Every year there is a radiation summer school run by GSI and ESA. The applications for this year are closed, but if you are interested for next year, they'll be reopened in December. So that's a really good hands-on experience with accelerators and facilities and doing tests and those kinds of things. So, okay, I'm in reasonably good time. That's good. The key messages here from what I've said, and I want to put across what I see as the changes from the past to the present, are that we have these 2 types of science: exploration focused and exploration enabled. Exploration enabled you can think of as nothing changes. We still want to support all the kind of science you could do opportunistically, but exploration focused has a strong radiation connection because it's the science we need to do to allow us to fulfill the strategy and vision that we have for the next years. I didn't mention in detail before that when we have principles of open science and open software, and we are still in discussions how that really comes about to make all the tools and data available, but they will be similar to the things that have been mentioned yesterday, but it's more just a philosophical point. I mentioned the radiation facility definition team. I mentioned it again because, as I said, I think for me it's the most important thing from this presentation for this community. And beyond that, I will also be trying to construct a radiation science roadmap. It's more like a 2-year goal, I would say, to not just for instrumentation, but for all of the science, to see what we need, what are the priorities, and how we're going to get there. If you can tell by my tone that I'm still thinking through how exactly we're going to achieve it. Just as a bit of overview for those of you that probably are not familiar with any of these people, but they are the key science people within exploration, and it's worth knowing who they are. So my boss is Angelique van Ombergen. She's the chief exploration scientist, and then we have 3 science team leaders for the different destinations. So that's Sebastian Vincent Benoit, James Carpenter, and Gerhard Kimnick. And then my colleagues Christian Hahn and Anne-Catherine Brasil working on biology and human exploration science specifically. So then I sit there on the radiation. And what I would point out is that you can see there's not that many of us. And one of the first recruitments they made was someone working in radiation. And that should also send a message as to how it's perceived. Last point, I think, from me is that there is this exploration science newsletter, and you can follow this link. You'll see in the link it says SciSpace. Some of you might know that terminology. It stands for science in the space environment, but it was really the exploration science before this rebranding. So if you see SciSpace, it's now exploration science, and I much prefer exploration science because for me, I always thought SciSpace should be something from the science directorate, but it wasn't. And I think that's it. So thank you very much for your time. And if there are any questions, I think we have 5 minutes.
Trying to open this. Okay, wait.
You start with Alex. Yes. Keep that. We will need to answer. Okay.
2 questions. It is planned to return samples from Mars.
So Mars sample return was a planned mission, ESA NASA mission. I mean, they were picking up the samples now. ESA was intended, well, the intention was, I don't know what tense to use any longer, to have the Earth return orbiter. So that's a project that is quite advanced, let's say. But of course, with the NASA skinny budget, the intention is from their side that they cancel that program. And if they cancel that program, then I do not know if ESA would try to look into other partnerships where they could achieve the same goals. I understand that NASA wants to just send people to Mars and bring the samples back, but that seems a bit more of a longer term goal. But yeah, it's a little bit up in the air. But the message from the US at the moment is the intention is to cancel that program. So I don't put too much faith in it being there, but we don't know what Congress will say, and I really can't speak more to that.
And the second most important question, is there some official document that we can refer if we are applying for funding for this strategy?
Yes. So if you see all the QR codes in this presentation, they all link to the exploration strategy and things such as this. In the past, we had a series of white papers. I think there were 15 of them covering all the different kind of scientific subdomains. But I think the most important thing is the overall exploration strategy and the science implementation plan for that strategy, which you can find on these QR codes. And if you don't find it, just message me and I'll send them to you. But those are the best references, and you should absolutely hang any proposal off those things in some way.
Thank you.
Yeah, thank you very much, Piers, for this nice and interesting overview. So my question would be, for example, there's a lot of things which which I think the roadmap can be very nice for, because you can put up specific goals you need to monitor, for example. And my question comes now in, there are monitors which are available on ground. So I'm talking about the neutron monitor network, which for galactic cosmic rays would be a really quite a good system, adding a decent and cheap instrument in space. So not a big one like the CERN instrument and things like this, but rather decent other instrumentation. Is this things also welcome in parts of proposals, investigations, and so on? Well, what about these ground-based additions or supplements?
Yeah, I see your point. I think if it was a proposal to build new neutron monitors or maintain the existing ones, it's probably not going to work in the context of an exploration strategy. If it's in terms of utilizing the data that you get from there, then of course it can be valid in proposal. I think that it's been a long documented problem, maybe globally, but at least within ESA, that whose responsibility are those neutron monitors, are those assets. And I know that space safety colleagues have been kind of taking small steps in that direction to see if they should be maintaining and developing those kinds of things, which are a very efficient way for getting the data that you need. But I don't think that exploration will be funding design, development, and implementation of neutron monitors, but use of the data, yeah, sure.
Well, I mean, I'm not talking in funding new instrumentation in that sense, but I fear simply with the political situation going on that we will expect similar cuts and things over there. So Europe should maybe have an idea on how one could keep the ones, because for the galactic cosmic ray investigations, these instruments are quite good, and you don't need to have a lot of them around, because you can do that with a few.
Yeah, I think what I can do and what I will do is to talk to colleagues across ESA, I mean the science director, but also space safety people, and say, okay, how can we address this problem? Is there some way of pooling resources or just identifying a program in which that could be done? I cannot make any promises. I'm pretty sure that in the exploration roadmap, it doesn't have visibility, even though you might say it should do, and we can of course bring some visibility to it.
Yeah, I'm just thinking about, because with this kind of monitoring in the back and the high energy range, you can easily build a very cheap, quotation mark, cheap and stable instrumentation for space near L1, and which be on a spinning satellite. So what I don't like on the CERN instrument is that you cannot measure at the same time your local environment, which I think is extremely important also for galactic cosmic ray investigations. So if you just measure forward by galactic cosmic rays, it's like, I mean, Mattea will talk a lot about these things. So the characteristics of the interplanetary medium is very important, and directionality is important, and so on. So maybe this is again something which could be done in a proposal.
I think it's certainly something that can be considered in this roadmap, radiation roadmap that I think about. Like if it's a whole, then it should start, of course, with some kind of gap analysis. And if it's a potential gap for the future, we have to see how it's filled.
Okay, and the other thing is, when one wants to apply for things to be involved in what's going on in the future for the next generation, how would one do it in a sense? Do you need already a big consortium to apply, or is it a small consortium, or how is the idea behind this approach?
So right now, this exploration focused is an intention and an idea without even on my level knowing how those contracts look like. Are we talking about giving 100K to do some specific research in a short time period? Are we talking about giving 500K or $1 million for multi-year kind of things? It's not clear to me. I would say, and I'm going to sound like a stuck record here, but for now, the most interesting to do is for people who care to to apply to be on the facility definition team for the instrumentation side of things. And I think by the end of that, we'll start to get a clearer picture of how exactly that's done. Bear in mind, because we're pre-ministerial, what we're doing here is we're telling member states, we intend to spend some of your money on science, like directly. And then they need to sign off on that in November, and then we can do it. And then we'll see how it's done and on what level it's done. So I think it's something that is coming, but you're not likely to see these ITTs in the next weeks.
Okay. Yeah, thank you.
So you probably said this already, but it's the money will be taken from the core funding of ESA on the science part, or is it an optional program that you're aiming at?
These are kind of good and important questions, because inside ESA, I fully understand how things work, and then I present to you lot and you go, you have misunderstandings. Exploration is an optional program, right? The science program is mandatory funded, and we are not touching their funding, so they will do what they have done, or maybe, you know, I'm not involved in science. Well, I'm not involved in the science directorate, so maybe their strategy looks different, but I understand that it will not change anything on that side. This is the proposal purely for HRE, human robotic exploration, where we also do science.
Okay.
But that program is and has always been optional, and it will not interfere with the budgets there. Of course, I and others like me, we talk to our counterparts in science on a scientific level as well.
Okay, it's important because we're organized around the space weather optional program S2P. And so at the national level, we coordinate up to a year before the ministerial, even more, national calls of ideas. We collect all this, and then we build a budget that we then bring forward to our representatives, to the space agency, CNES, and convince all the different bodies in France that it's a good idea to put money on this program. So if this is going to be a space weather oriented activity in another optional program, then at the national level, we need to think about how to position this and put some dedicated funding.
So I didn't speak too much about that, and that I think is important. Sorry to overrun by a couple of minutes, Thanasis. We are not planning to duplicate what they do in space safety. However, I consider that a program that has many valuable aspects. I mean, they're not just dealing with space weather, they're dealing with planetary defense, they're dealing with debris. They have a lot of different proposals in their program, and what they can fund depends on what the contributions are given are. Now, when they come to us and say, okay, we can give you this kind of space weather service, it's highly likely that we will say two things. One, we want this on top, because for exploration, we specifically need these things. So we will fund them and probably create a joint system that leverages, let's say, put some details on it. We're probably not going to fund MHD simulation stuff, but we might fund the particle transport that builds on top of that, right? That would make sense. So we will definitely be talking to them, and I'm not here to tell you to take money out of space safety and put in exploration. I think in any case, that's not the phase we're in. There's no action on the lobbying, I think, for your side now, unless someone rings you up and says, is this important? Then say yes. But I think this is more an indication of what is already intended to come, and only next year will we know what the details are. And there was something else I wanted to say about it. Yeah, so we will have an operational radiation protection service in exploration developed, which will take as input what comes out from space weather and space safety, and uses that. So we're talking to them still. I'm still friends with those people. No worries.
Sure.
And,
I mean, it means that there might be some reorganization of the way we implement our preparation of the ministerial at the national level, so that we flag this activity in the robotics optional programs.
I guess for the next 6 months, if something comes up, it's more to say, look at Explore 2040 and look how this has additional benefit for that program, that's worthwhile saying. I don't think it's worth trying to tear up all of the preparatory work that's been done in the last 6 months, that kind of thing. Maybe 3 years' time it will look different, but then we should have a clear idea of where the responsibilities are. But for me, it's more kind of teamwork, but we have specific needs, and I can't expect that space safety spend all their funds just answering those needs, so we have to answer them as well.
Okay, but it also implies something like monitoring. So that means that if you can, I mean, for several things you need simply monitoring. For example, we heard about radio science. So imagine our American colleagues, which are very clever. I mean, the colleagues are clever, but the administration might be not as clever, will shut down wind, stereo. So there will be no radio observations at all for this kind of purposes. And I think it comes out that this is really quite an interesting thing. Monica did work on this for the forecasting and things like this.
I think those are space assets. They are eligible, I would say. And I would also say, who was mentioning the Mars observations beyond LIM? I mean, Mars L5 is probably a point you want to make measurements of. I already said, within ESA, that's the kind of thing that we need to do, right? Because if you really care about protecting astronauts and you're going to go to Mars, in the end, you're probably going to need a Mars Sun L5 observing spacecraft. But those kind of things, even though they're not radiation instrumentation per se, they, I think, are eligible. As long as we can identify a gap, we need to.
I mean, there we are going to this L4 mission, which is space radiation-wise much more important than the L5 mission.
I meant L4. I meant Sun, Mars, L4.
Okay, so sorry.
My apologies. Sorry, I said the wrong thing.
So I think that, I mean, it would be also good to have on L5 a decent particle instrument, because you can do this radiation, because I'm not quite convinced what was presented that you cannot use stereo or this kind of stuff for using as the release system towards Mars. So I'm still think there's a lot of science we need to do right now with MSL and MAVEN to do prediction. I mean, we are talking about different energy ranges and it's a shielding on Mars, but if you're on a spacecraft, so whatever. Okay, but this would also fit into your ideas.
Indeed, I think so.
Okay, thanks.
Thank you very much, Piers.